Welcome to everybody. Uh, this weather briefing will be two parts, or maybe three. The first part, I will discuss a little bit about last week weather situation in Hungary, but in this picture you can see a photo which was taken by my colleague, who is also Kornel actually, at the top of our building, and you can see some nice high-level clouds. Actually, these are partly water clouds and ice clouds, and you can see some virga in here. If we check the satellite images, we can realize that these are really partly water clouds and partly ice clouds. With the elevation is about 7 kilometers, and the temperature is well under 0 Celsius. It could be around -20, -30 degrees Celsius. But as usual, we can start with some annotation from you where you can indicate your places. So you can put some arrow or text on the map where you are watching this event. Yeah, and I realized that some of you already wrote in the chat box that you experienced some nice weather. Yeah, thank you. And yes, we have a huge ridge above Western Europe, and because of that ridge, we experience warmer temperature. And in the following 24 or 48 hours, the airstream will bring even warmer air in Europe. Yeah. Okay. So, but before we jump into the discussion, okay, I will close. Yeah, because before we jump into the discussion, I can show you some nice pictures because some winter weather already happened in Hungary last week. So you can see that the weather pattern was quite busy in these days, even though the last Sunday we experienced just anticyclonic calm weather. So this picture was taken in a Hungarian mountain, not big mountains like Alps or Carpathy, but it's a small mountain. The elevation is around 800 meter, 900 meter, but we experienced some nice snowfall. But actually, it wasn't just nice, but these kind of events could be dangerous in some situation in autumn or also in spring, because the leaves on the tree are still there, and the wet snow load could be so high that the trees could fall down. So the picture was taken in this place, in the northeast part of Hungary. It's called Bück, and some roads was closed for 1 day or two. Actually, the event was very local because you can see the maximum temperature in that day in Hungary. So it was well above 0 most of the places, and also around the Bück mountain, it was also the maximum was also much higher than 0 degrees. But that places experienced intensive rain and showers, and at the mountainous area, the precipitation could push down the temperature around 0 degrees Celsius. The weather background was behind the cold front. The temperature at the 850 hectopascal were around -2 degrees of Celsius, and in the northeast part of Hungary, but that was enough for snowfall. And the precipitation also were very local, because it was just happened in a narrow convergence zone in northeast part of Hungary. You can see the stratification profile close to Bükk Mountain. So it was because we were situated behind the cold front. It was a little bit unstable stratification, but the air was quite humid. So the precipitation amount was above 20 millimeter, and the intensive showery rain and snow rain, and then wet snow happened at the top of the mountain. Yeah, okay. I planned to jump into the current weather situation, if I can, and I planned to just show the e-port online. I hope you can see it, and I wanted you to annotate the approximate position of the warm front. Now the green lines, the ISO lines, are the thickness ridge. Yeah, I should allow the annotation for you. Oh, how? Allow to annotate, and some of you. Okay. So if you know the thickness ridge, and if you see the if you see the satellite images as well, you can try to annotate. I don't know if I managed to allow it or not. You can put even text or draw a line. Just, yeah. Okay. Yeah, this one from the north part of Great Britain and to Hungary is quite obvious, but okay. Some of you already annotated the other one, and these are double structure actually. So there is one warm front. Okay, I will erase. Yeah. Okay. Stop annotating. Yeah. And so you recognized two warm frontal bands, and because of these two frontal bands, we also have two jet streaks. One is around the north part of Great Britain to Poland, and the another one is the north part of Scandinavia. Okay. Okay, and we have some nice trough also in the southeast part of the Mediterranean, and ahead of this trough we still have some convective weather in here. Actually, if we see the lightning maps, we can see the lightnings in the south part of the Mediterranean. If any of you have some tips, what should we check in the current weather situation, please share with me. Or maybe I can have one question for you. Can you find the upper level low around Europe? Maybe I can show a mean sea level pressure. So that's the mean sea level pressure. And I switch the or even the airmass RGB or the water vapor. So can you show me the, okay, maybe I annotate, yeah. Can you guess? Exactly, exactly. So on the, yeah, exactly. So the mean sea level pressure cannot show closed isolines, but if we switch to 3 hectopascal, it will be a nice closed structure. Yeah, but the main feature, of course, in Europe is the warm front and the warm advection. I want show you synthetic infrared images from, oh, okay, yes, yeah. So these are not the real infrared image, but a derived infrared image from ECMWF humidity profile and the cloud profile. So this is today morning, and we will see the development of the features. It's today 12 UTC. You can see the cold front, a warm front, or a thickness ridge cloudiness. I am not sure if it is warm front or exactly warm front or not, but the ridge is obvious, and the airstream is stronger and stronger because behind the front there is another trough or cyclone which goes from west to the east, and actually tomorrow this cyclone or upper level trough will reach out the front, and I think that is the instant occlusion conceptual model. But if you don't agree with this, we can discuss it later. Another interesting stuff to see on these synthetic infrared images are the wave patterns. So this is tomorrow evening, for example, and you can see some waves also on the infrared image, and some lee cloudiness around here, for example, or around here and here. And also on Thursday morning, there will be some lee cloudiness in here. Yeah, and I want you to guess that tomorrow afternoon, when, so obviously the warm air is coming from the southwest, but so some higher temperature will be around Spain and the northwest part of Africa. But can you guess if the airstream is this strong like this one? Where will be another maximum of the temperature, maybe around the level of 850 hectopascal. So you can annotate some places where you think that the temperature will be the highest. Yeah, okay. Hopefully all of you can annotate. So the airstream is from the southwest. We will have a huge ridge in Europe, and can you spot some places when, yeah, okay, one guess is there. Yeah, there should be a secondary maximum because of the, yeah, some of you are annotated. Okay, okay, I will stop it, and you can see the answer. So one obvious maxima is in here, but the another one is just north east part or in the direction to the north east from the Alps. So tomorrow afternoon, according to the ECMWF forecast, the temperature at 850 hectopascal will be almost 17 degrees Celsius. So it will be interesting to see the maximum temperatures at 2 meters around Central Europe. Maybe some of you can put in the chat box what is the forecast in your country, but now we can jump to the second part of the presentation. So I will stop sharing, and Zsofia will continue. If you have question, of course, we can discuss it. Thank you.
Thank you, Kornel. I will then try to share my slide. I hope you can see it. Presentation mode. So I welcome also everyone, and thank you, Kornel, for this nice overview of the current weather and last week winter weather in our mountain. And when I was hiking at the beginning of October, I was actually in the mountains up in the northeast part of Hungary, called Zsofia, and we were experiencing a fog situation in the village where we started our hike, and went up to the mountains and was looking down at the fog, and I was thinking that this could be a very nice case or start of the talk about a little bit of fog detection in the weather briefing, because I was thinking we are in our ways to in our way to the autumn and winter with quite a lot of fog ahead of us. So when I was looking at this fog from the mountain, I was thinking how would it look in the satellite? Would we see it or not? Here is my first question to you actually, is okay, I think you all should be able to annotate now. If we can detect fog only using satellite imagery, this can be a tricky question, but I did put the definition of fog here. And my other question is, are you certain if you see something on the satellite imagery that it is a fog? Okay, now we have even in the yes and no's. Probably a little bit more on the no. Yes, I think that's why it's a tricky question, because if we only use satellite imagery, then we are only looking at the top of the cloud, meaning with the summary, with the geostationary imagery we have, and we have the fog definition that fog differs from cloud only in that the base of the fog is at the earth of the surface. So yes, the question is if we see the surface or no, and you are right, we cannot use only satellite imagery to really know for 100% sure that we have fog. So here I have put an animation about this case when we were looking here. If we look here in the Microphysics RGB, then we are around here and looking in the northeast part of the mountain where we have the foggy area. Here we have the HRV fog RGB, the 24-hour Microphysics RGB, we have the natural color RGB, and also we have the no castings of cloud type product, which have a category of low clouds and very low clouds. And here we see this is very low cloud, but this is made from using the top of the cloud, of course, and also NWP data. So the next part is, as we already talked about, we cannot distinguish between fog and low cloud because we only see the top of the cloud. And we have also a problem of fog and low, if the fog and the low cloud is covered by thick high-level clouds, because we cannot see under, as we have already established. And also if we have semi-transparent high cloud above the fog-low cloud, then it can be problematic, especially during night, to detect that part. And as already said, that the separation of fog and low cloud is very difficult, but there are some methods. If someone uses other type of data, then it can be estimated the cloud base as well. But this really needs additional information besides satellite imagery. So the next question for you: which RGB would you use to detect fog during nighttime? And I would like you to pick one which you think would be the best. Okay. Quite many of you have. Okay, all of you are. Okay, one for the 24-hour Microphysics RGB. All of the other, one of you is voting for the night Microphysics RGB. Yes, you are right. The night Microphysics RGB is good for fog detection at night, and also the 24 hours Microphysics. Good. Now talk about a little bit about the night Microphysics RGB. We are using channel differences in the red and green beams, and we are using the 10.8 in the blue. Here we have an example of how the fog looks like in this image. And before we go into the details why we can use this image, I would like you to think and also use your marks to indicate which of the color beams are helping in fog detection. What do you think? Is it the channel difference? Okay, the green beam has information on fog. Any other votes? Yes, the green. The green. Okay, we have one vote on the red and on the blue. Okay, the most is on the green, and I too agree that green is the one which helps us to distinguish or to detect fog. We are using the 10.8 minus 3.9 in this green color beam, and actually this is a very simple method used here. We have the difference of these two channels, and that is because the small water droplet has less emissivity in the, I'm sorry I mistyped it here, but 3.9 should be here as it indicated by the arrow. Then in 10.8 here we have the, we can see that the emissivity is lower for the water in 3.9 than in 10.8, which means that it reflects the cold air above, reflect the cold air above more than in 10.8. So that is the reason why we can detect a fog, and also the surface has a little bit different emissivity, and that's why we can see it very nice. But it has a problem when we have dawn and dusk, and when we have very cold conditions. That's also a problem, but this happens very rarely. But in that time we can also use the 24-hour Microphysics RGB, which uses the, in the color beam, instead of using the 3.9, we are using the 8.7, and this has the same principle that the small water droplets have less emissivity in the higher 8.7 than in the 10.8. So here we have an example loop of the 24 hours microphysics, and I would like you to annotate where you can identify areas with fog low-level clouds in this image. So you can use your tools. Yes, exactly. This is the color where we have the fog and low cloud. Yes, very good. Very nice. So now we can move on to the daytime detection, and if you have to choose one imagery, one satellite image to detect fog at daytime, which one would you choose? Yes. Yes, I see that first choice is the HRV fog, and then we have the 24 hours microphysics. Yes, the 24 hours microphysics is very good because you can see loops during the whole day, and that is very nice. And also the high resolution RGBs are very useful. Here we have the high resolution fog RGB, and we have HRB provides very high resolution information on the cloud structures and thickness. If we have small areas with fog, that it can really help us to see the fog. And also we have the near infrared 1.6 channel, which helps discriminate snow-covered land from fog or low water clouds and from ice clouds. Here we see that snow is with the cyan color, and we can clearly see where we have some snow patches here next to this area with fog. And why this channel is helpful? Because the reflectivity of the snow is much higher in the HRV than in the near infrared 1.8. The HRV is, let's say, it covers very large or area of the spectra, but here we see that the snow has a higher reflectivity in this this channel than in the 1.8. So snow will be bright in the HRV and dark in the 1.6. And the water clouds, this is not shown in the image, reflect much of the radiation in both channels. So this really helps distinguish between snow and water clouds. And for the ice clouds, you can see that in 1.6, ice has higher absorption in the 1.6, which is with this dashed red line, and for the water with the blue line is much less. So the reflection of the ice cloud is lower than the one for the water cloud. So that is why we can distinguish between ice clouds and water clouds in this channel. So here we have a quick example. If we are looking at different RGBs, we can see where we have this low-level foggy area, and here we have the difference between the snow and the cloud-covered area in both the day microphysics, the HRV cloud or fog, or the natural color, but we do not see this in the 24-hour microphysics because we are only using higher channels. But we can see much better the low-level cirrus clouds above our foggy area, which is not really seen in the other RGBs. So just at the end, one other product which can help to detect automatically low-level clouds is the no-casting of cloud type product. We have different categories, which I will not recall all of them here, but we have one category called very low clouds and low clouds, which has information about above the top of the cloud. So if it says very low clouds, then you have to bear in mind that this is about the top of the cloud. And one other thing, that during nighttime there is no snow detection in this algorithm, so you will have some differences during night and day. So do not. So just remember that the snow is disappearing during night in that product. So with that, I would like to thank you, and this was just a little bit of recap about fog detection before going into the season. I thought it would be helpful. And if you have any questions, either for me or for Kornel, do not hesitate to ask.